Welcome to QDL. QDL is your look at who and what is making news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest. As we know, the pressure for industry to reduce harmful emissions and greenhouse gas emissions in particular has really increased significantly in the past few years. In fact, recently, President Biden set an aggressive new target for the United States to reduce net greenhouse gas emissions by 50 to 52% from 2005 levels, and to do that by 2030, so basically 9 years from now. In addition, in December 2020, the European Union agreed to cut greenhouse gas carbon emissions by 55% by 2030 compared to 1990 levels. So, as companies are eyeing reducing their emissions, whether because of regulatory requirements or because it's a good thing to do, emissions are waste and waste is money, so it's a good thing to do anyway. So of course they're looking for their biggest sources of emissions in ways to decrease those emissions, and sometimes the fastest, most cost-efficient action is to simply update outdated equipment. One of those pieces of equipment that we're going to talk about today that many industries use are gas and oil-powered boilers. Today we're going to look at a new, old technology that could replace those fossil fuel-based boilers. These are called high-voltage electrode boilers. With us today is Robert Presser, Vice President of ACME Engineering. ACME Engineering makes, no big surprise, high-voltage electrode boilers. Hi, Robert. Thanks for joining us.
Thanks, Dirk. It's great to be here with you today to share a little bit about this new technology that's been around for about 100 years and is enjoying a resurgence in the marketplace because of just that, political decisions and incentives to reduce emissions.
And it's an interesting technology. And I guess I never thought of how these things would work, even though I've heard of them. Can you tell us briefly just how an electrode boiler works? And in fact, I think I've got a diagram here we'll just throw up on the screen, and we can just kind of talk about it a little bit as you talk. So let me just share that. Okay, you should see that. So that's a kind of a schematic diagram of an high voltage electrode boiler, right?
Sure. So what you're looking at here is the hot water version of an electrode boiler. And what's important to remember about this design is the hot water is generated in a closed loop. You can see all the way on the right side of the diagram, there's a heat exchanger there. So we're circulating pretty much the same hot water around and around into the boiler and exchanging the heat with whatever process fluid you've got on the other side. It could equally be water. It could be some kind of processed fluid like glycol or whatnot. So it could be thermal oil. Who knows? That's up to you. But on our side, we just heat our water that has been treated and has chemicals in it to give it conductivity. So the first thing you've got to know is it's called a high voltage boiler because it takes high voltage. And that can be anywhere from 4160, which a lot of plants have, that's 4,160 volts, all the way up to 25 kV directly online. So the advantage is the higher the voltage you can take and the higher the voltage you've got coming from your transmission lines, the smaller the transformer you need to bring it down to run one of these boilers.
Sure.
So how does this thing work? You've got 3 electrodes, one for each phase of 3-phase power, and you have charged those electrodes. They are now immersed in conductive water, but nothing happens until you raise and lower a shield that isolates each of these live electrodes from the ground or the neutral shell.
Yeah, let me interrupt. Let me interrupt just for a second here, because I do want to kind of explain what I think I'm seeing on here. So the electrode is this green bar that sticks down in there. That's high voltage. That's like 4 kV up to, I think you said 13 kV.
25 kV.
25 kV. And so it's actually the current flowing from the electrode to neutral through the conductivity of the water that heats the water, right? Just the current through a resistor essentially is power. So
exactly correct.
And then then you've got this, you said you were raising what, the shield right here, right?
Yes. So there's a screw drive that raises and lowers the shield that isolates the live electrode segment, which is the black part that you're looking at. So the more of that is exposed to the neutral or the ground on the other side, and you can see the shield is really, really close to the electrode, and the receptor, if you like, is further away. And you change those distances based on voltage, by the way.
Okay.
The more you expose, the more heat you're going to generate, and the more capacity is produced by the boiler.
Interesting. So you don't change. So you change the output of the boiler based on raising and lowering the shield, not by changing the input voltage at all.
Correct. You do not play with your input voltage. That's coming from the grid. The last thing you want to do is start varying your supply voltage, because it's going to bounce back onto your network system. So you set that. Also, you generally set your conductivity level, which in this type of boiler is 300 microsiemens. But if you want to start playing with the capacity of the boiler, you can also vary your conductivity.
Okay.
So there's two ways to do it. You can play with your conductivity, but we prefer that you leave your conductivity alone and you only use shield to control the capacity of the boiler.
Interesting. So I noticed, yeah, you do have a conductivity sensor up there. So you're constantly monitoring the conductivity of the water to make sure that it stays at the level that you want.
Correct.
And so and I'm assuming this chemical treatment tank down here, that's helping to balance that. That's what's putting chemicals in to raise the.
Right. So you have periodic injection of new chemicals. If your conductivity is too low, there's also a purge if your conductivity is too high.
Okay. And then you're just bringing in city water. I mean, nothing special about the water you're bringing in, right?
No, you've treated your water, but you've treated it once, literally.
Okay.
You have put in nice, clean water, and hopefully your city water is good.
Okay.
Right? Because the last thing you want is rust-filled city water.
Right.
So, because that's certainly going to affect the performance of the boiler. Though I have seen some installations where the thing was even fed with dirty water and the boiler survived. The nice part about this boiler design is that it's very simple and very rugged. It's designed to live under unfavorable conditions. So you can have a client, we have clients for these boilers in China where they're at a mine thousands of kilometers away from any trained service personnel. So this thing has to be simple enough and rugged enough that it survives in the field.
And it's interesting. And so is that behind you? Is that one of your ACME? Yeah, it is one of your boilers behind you, right?
Yeah.
In the image there. Okay. So those look like they actually have a much smaller footprint than what I'm seeing from traditional fossil fuel powered boilers. Now, are these simply a smaller output, or if this was a comparable gas fired boiler, would it be a much bigger unit for the same output?
No, these units are very compact. You're looking at a couple of 8 megawatt boilers that were produced by our Chinese technology transfer partner. And I believe these are the ones that went to the mine that I just talked about. They have a much smaller footprint. Obviously, you're not feeding them any fuel. You're only feeding them electricity, and they're quiet.
And they're super efficient, if I understand.
The loudest noise you're going to hear from these things is the circulating pump.
Wow. So, and the efficiency is like almost 100%, right? 99.9 or something like that. Okay. And what a fuel, even a pretty efficient fossil fuel powered boiler is what, maybe 85%, 80%?
If you've got it in tune and you're using it to its maximum designed capacity, you will get, say, 85% out of a good gas-fired boiler. However, if you're running it at lower capacity and you haven't paid attention to your burner, you're nowhere near that.
And that was the other thing I want to talk about, is these, in terms of there's a term you use, I can't remember what it is the minimum amount of flow that through it while keeping the unit running. There's a name for that.
Your turn down ratio.
Your turn down ratio, thank you. Your turn down ratio is much better on these than on fuel boilers, right?
On an electrode boiler of an immersed electrode design, remember, these are hot water boilers behind me. Yeah. So the minimum output is somewhere between 5 and 10%, depending on the design. Now, we have a second design, which is a jet type boiler that produces steam. And there you have perfect 100% turn down. So you can, and what's nice about that is on the steam boiler, you can leave it in hot standby, meaning you leave it at pressure with a small immersed element, just keeping the boiler warm, say to 70 or 80 PSI. And you can bring this boiler online to full capacity in 90 seconds. There's no other boiler that's going to do that for you but a high voltage jet electrode boiler.
Okay, so the technology is interesting. I mean, like you said, this has actually been around. I think you said, you told me earlier offline, these have been around in Europe, in Scandinavia, I understand, for quite a while, right?
You know, they've had their days. GE made these things in the 1920s and sold a whole bunch of them in the US, and then oil came around and killed that, except for certain markets where hydro was available and electricity was cheap. Then there were government policies. I mean, in Europe, in Northern Europe, where you always had hydro, you always had electrode boilers. In Switzerland, where you had a lot of hydro, you had a lot of electrode boilers. We sold a whole bunch of them in Canada during the 1980s when electricity rates were adjusted to favor the large-scale industrial consumption of electric. So we sold over 800 megawatts of these boilers at that time. Then later on in the 2000s, we produced a bunch of boilers for the States again in partnership for people who had available power. But now it's more than just an economic argument. It's an emissions situation where people don't have a choice. It's an ESG political or policy decision by companies. You say, I want to be a green company. I'm going to reduce my water use. I'm going to recycle my plastics. I'm going to try to be carbon neutral. Well, your boiler plant is a big part of that process to become carbon neutral. So you've got to start looking at where you're burning fossil fuels and what you can replace them with. And an electrode boiler is a good answer.
And I was going to say, so that's you just discussed one benefit right there. What are some of the other just practical benefits? You know, the low turn down ratio, I think you mentioned was one. You know, obviously fewer emissions. What are some of the other benefits if somebody's been used to a gas or oil powered boiler? What are they going to gain when they switch over to an electrode boiler?
Well, you really have very precise demand matching with an electric boiler. Unlike, say, a gas-fired boiler where you have time to ramp up and then you have a flywheel effect. There's no such thing as taking a gas-fired boiler from 100% to zero in 90 seconds, whereas we can go up to 100% in that time and bring it back down to zero in that time. So if you have a process that has peaks and troughs and you're worried that your boiler is not going to match it, with an electrode boiler, you will perfectly match your demand.
Wow. So why haven't these, I mean, given that they have a lot of benefits, I'm guessing maintenance is probably less on these too. Given that they have all these benefits, why haven't they been more widely adopted, let's say, here in the United States?
Well, in a lot of markets, electricity for industrial consumption was expensive, and gas for a long time was cheap. And I saw the spot price for gas this morning, you know, approaching, I think it was $5.88 Henry's Hub, and that's an incredible price. And so if they weren't thinking about electric before, they're certainly thinking about it now, because even with high electricity pricing, all of a sudden these boilers make sense.
Right. So where do you see, I mean, do you see or have you seen the market for these grow, given what we've just talked about? Have you seen it grow in the United States?
There is increasing interest in the United States for district heating. You know, we've spoken to utilities who have these massive boiler plants that are stuck feeding steam lines all over major city cores, New York City in particular, and they really want to get away from the emissions in urban centers associated with that. And at least with an electrode boiler, you can replace a battery of huge gas-fired boilers with a unit like this. I mean, we can put in 52 megawatt boilers and string them along, and all of a sudden you've got 300 megawatts of steam power in your city core and no emissions.
Oh, okay. Okay. So there is some growing interest in this then.
Yeah, you've got to realize there's a whole generation of engineers out there, even 2 generations, who all they knew was gas.
Yeah.
And so now their clients or government is telling them, you got to go electric, find me a solution. And they're looking left and right and going, what can I use to replace a huge gas boiler? Well, this is here, and it's always been here.
Yeah. All right. Well, it's interesting technology. I mean, it's the technical part of it was interesting to me. Just the way it works. As soon as I read that you've got electric current flowing through conductive water, and then it in itself converts to heats up the water internally, so to speak. I was like, well, yeah, that's really kind of a simple idea, and I'd never even thought about that before. It's really interesting. So thanks. Go ahead.
The kind of science that most people can understand.
Yeah, exactly.
So it gets you over the hurdle of when you're talking to engineers or plant managers, that if they understand the concept of conductivity and resistivity, then they can certainly get their head around an electric boiler.
I'm guessing do you ever, I would imagine it have to be somebody pretty naive, but I was there exactly, so I'll say that. That when you think, an electric boiler is just like a big water heater that you have at house. You know, you've got heater coils basically immersed in water, and that was my first thought. It's like, well, I could see where that would work. It would be kind of inefficient, but it's not that at all. And do you ever run across that even with professionals where they just think a big electric boiler is literally that, like a big home hot water heater, but larger?
Well, we make resistance element boilers as well, and we've made some pretty big resistant element boilers up to like 3 megawatts of size.
Okay.
But try to get your head around how many amps 3 megawatts of resistance elements is going to draw at a typical voltage like 480.
Yeah, right, exactly, yeah.
So it's just unsupportable for most customers. So yeah, you want a 1 megawatt boiler, a 2 megawatt boiler in small size in resistant element design. Sure, we can do that for you. But at a certain point, it becomes uneconomical to build, say, you want 10 megawatts of hot water. I'm going to have to string together 3 or 4 of these massive amp-loving resistance element boilers, or I can give you one like those behind me with a small footprint. Yeah. Just go find the voltage. Go find your high voltage somewhere. Yeah. And a lot of plants have at least 4160. Okay. Some of them may have 10 or 11 kV. 13.8 kV. These voltages are around. There are a lot of industrial facilities who have it already.
Yeah, that's interesting. All right, interesting technology. Robert Presser, Vice President of ACME Engineering. Thanks for joining us. Really appreciate it. Very interesting topic. All right, and that is it for today's QDL. Thanks to all of you for joining us. If there's some technology you'd like us to talk about or somebody you'd like us to bring on the show, just let us know. Email us at qdl@qualitydigest.com and we'll get them on here. Thanks for joining us. We'll see you at the next QDL. So long.